told you it would be right. 6.28, we're dealing with polynomials again. That's what we did yesterday. Remember we talked about like linear, quadratic, cubic, all that. And we talked about monomial, binomial, trinomials. So we're dealing with those today. And yesterday we did standard form, which meant there were no parentheses. All like terms were combined and they were written in order, descending order of degree. Okay? We're dealing with standard form again today, but we're also dealing with factored form. Factored form of a polynomial. To be completely factored, all factors must be linear, meaning their highest degree is 1. So any x's, they have to have the degree of 1, nothing higher. So no x squared, no x cubed, no x to the fourth, so on and so on. We will really deal with that in the second type of problem that we do. To start out, here we're going from factored form to standard form. Okay, so we want to get no parentheses, combine all the like terms, and get it in order. So let's see, to start this out, we're just going to deal with 2 pieces at a time. So let's start with the first 2 pieces. We've got 2 binomials, so we should FOIL these. All right, so let's see. First term times first term is x times x, which gives us x squared. Well, outside terms, x times 2 gives us what? 2x, good. All right. Holden, we've got inside terms, so 1 times x, what is that? 1x, good. And then Ty, our last terms, 1 times 2 give us 2. All right. So that's in parentheses, and we still have that last set of parentheses, the x plus 3 at the back. We just haven't done anything with it yet. All right. Inside our first set of parentheses, we can combine some like terms. These 2 right here, yep, it's 3x. So we get x squared plus 3x plus 2 times our x plus 3. Now we have a trinomial and a binomial. We need to multiply them together, but we can't FOIL because we have extra pieces, so we just have to plain old distribute. All right, so we're going to take our x squared and multiply it by everything in the back. So first is x squared times x, which gives us x cubed, because there's 3 of them being multiplied. Next is x squared times 3, which is 3x squared. So we're done with x squared. Now we move on to 3x. 3x times x. It's 3x squared again, because there were 2 x's multiplied. 3x times 3. It is 9x, very good. We're done with our 3x, and now we will deal with our 2. So 2 times x, 2x, and 2 times 3 is 6. Woohoo! We got rid of parentheses. So we're doing very good. Okay, now we need to make sure we've combined all like terms and that it's in order. So what needs to come first? What's the highest degree? The x cubed. Yeah, so x cubed comes first, so don't worry about that. Now we need the x squared put together. So that's 6x squared, good. plus 11x, good. And then our plus 6. And that is standard form, so we are done. So last step, combine like terms. So that was factored form to standard form. Let's do the next one. What should we do? Distribute. We got to deal with that squared first, the exponent. So what does that squared really mean? All right, so the x plus 2 happens twice. All right, now, do you want to deal with the front 2 or the back 2 first? Back 2. It doesn't matter. We're just going to go with what Big K said. So we got 2 binomials, so let's FOIL those. All right, so first times first is x squared. Outside times outside is positive 2x. Inside times inside is also positive 2x. And last times last is 4. And don't forget, we still have an x in front of all of it. All right, combine the like terms. Oops. So I've got x squared plus 4x plus 4. Okay, now distribute the x. So x times x squared gives us x cubed. X times 4x. 4x squared. X times 4 is 4x. Okay, parentheses are gone. Do we have any like terms to combine? No. Each x is different, has a different degree. Okay, are the degrees in order? Biggest to smallest? Yes, so that is our answer. Questions? The next problems, we're actually going to do the opposite of what we just did. We are going to start in standard form and end up in factored form. Remember, factored form, you're done when everything is linear. Okay, so that's like your stopping point. And you have actually done this before. Whether you remember it or not, I don't know. To start out factoring, you look for a greatest common factor. What's common between all 3 terms? There's a 2 and an x that go with all of them. We want to bring that out to the front. In order to do that, you have to divide everything inside. Okay, so let's just reduce inside. Let's see, the 2's cancel out. What's x cubed divided by x? You basically just take 1 away from the top, so it's just x squared. Okay, 10 divided by 2 is 5. What's x squared divided by x? Just 1 x is left, so plus 5x. Let's see, 12 divided by 2 is 6, and x cancel, so it's plus 6. So now we have 2 factors, 2 things being multiplied. The first one here is linear because it's got a degree of 1, but what about inside? We still have degree 2, which is quadratic, so we're not done yet. We got to keep going. So we just need to deal with this part here. Do you remember how to factor a quadratic? the big X. What goes in the top of the X? A times C. And what goes in the bottom? B. Okay, so what is my A times C? 1 times 6 is 6, and B is 5. What two factors of 6 add to get 5? 2 and 3. Thank you. Now I put those in my fractions. 2 and 3 are the top. What's the denominator? A, which this time was 1. Can we reduce either one of those? No. So I'm going to go ahead and write my X in the bottom. And my two factors are X plus 2 and X plus 3. Remember, the X goes first and then the numerator, X and then the numerator. So we factored the quadratic part, but what goes in front of those two factors? The 2x. Everything is now linear, so we are done. All right, one more of these. So start out, do we have a greatest common factor? Any number going to 6, 15, and 36? 3. All right, do they have any common variables? An x. They all have at least one. Okay, so we need to pull 3x to the front, so divide it out of each term. So let's see, 6 divided by 3 is 2. X cubed divided by x is x squared. So 2x squared. 15 divided by 3 is 5. Cancel one of the x's from the top. So 5x. And what do we get for the last term? 36 divided by 3. 12. That's close. All right, we're in the same situation as last time in that we still have a quadratic. So let's make our big X to factor it. So this time, what's A times C? We got 2 times negative 12, so negative 24, and B is negative 5. Okay, factors of negative 24. Let's see, 1 and 24, no, that's not going to get us there. 2 and 12, no. 3 and 8. Okay, 3 and 8. If we subtract them, they'll equal 5. Which one needs to be negative to make it negative 5? Negative 8. Okay, so we got 3 and negative 8. Now I go over to my fractions. Got 3 and negative 8. What goes in the bottom? Our A value, which is 2. Can we reduce one of those? Yes, we got negative 4 over 1. Okay, so what are my two factors? Let's see, 2x plus 3 and x minus 4. And what goes in front? 3x. Right there. Everything's linear, so that is your answer. This is a big piece of what we're doing tomorrow, being able to factor our polynomials down. It helps us with graphing. Yay. All right. Any questions? No? On this next page, I've decided that I do not like this problem. So, in a moment, we're going to do the word problem from your homework together, in a moment. But first, we are going to look at this bottom part. Side notes, or bottom notes, about cubic graphs. So cubic graphs, like I said yesterday, make this S shape, sideways S. It's like two parabolas put together. So it goes forever up and forever down. So it doesn't have a true maximum or a true minimum. But you do see that it's got high points and low points, right? So the word for those are relative maximums and relative minimums. Relative means like in being compared to things around you. So like between these two x-intercepts, we have a relative minimum. That is the lowest point between those two intercepts, right? And here, between these two, we have a relative maximum. There's a highest point, for sure, between those 2 points. Okay, that's what that means. Now, remember that x-intercepts are also, another word for that is zeros. On your homework today, it will ask you to find the zeros. Okay, and another word for them is also roots. Okay. Now your calculator can find all those things for you using second trace. There's options for 0, there's options for maximum, there's options for minimum. You're going to use those on 2 of your problems after the one we do. Okay. So at this point, go ahead and get your block paper out, and we're going to do the very last problem, number 15, together. Says a metal worker wants to make an open box from a sheet of metal by cutting equal squares from each corner as shown. Okay, so he's starting out with a 12 by 16 flat piece of metal, and he wants to turn it into an open box like this. It looks like a cake pan to me. I think he's going to make a cake. All right, so what he's going to do is cut out these little squares on the outside. So that'll be gone, this will be gone, and that'll be gone. He folds up the sides, and then they fit together like this. And he probably has to, like, weld it, right? That would be what you would do next to seal it. All right. So to start out, for part A, we write an expression for the length, width, and height of the open box. All right, so after the little squares are gone. So part A, we need length, width, and height. I think I'm going to start with height. Okay, so thinking about this, if he cuts out these squares, how high is this box going to be? Like the sides that he folds up, how tall are those? Really, it's not going to be very tall, but look it up here. So each square that he cuts out, its length is x, right? So that side that he folds up, how tall is it going to be? X. We don't know what it is, but we know it's x. Okay, so height equals x. Now, length. We're going to go from this 16 inches down to whatever this is. So 16 inches, what's going to be taken away right here? X. What's going to be taken away right here? X. So how would we write that? Close. It's going to be 16 minus 2x, because this just happened twice. So what does that make the width? It starts out at 12. What gets taken away from it? To x as well, because x is coming away from each corner. All right, part A is done. For part B, it says use your answers from part A to write a function for volume. What is the function for volume for a box like this? Just like general formula chart, what's our formula for volume of a box? Yes, length times width times height. All we have to do is plug in what we wrote down. So volume, instead of length, I'm going to write 16 minus 2x. Instead of width, I'm going to write 12 minus 2x. And instead of height, I'm going to write x. Now it told us to use factored form. So basically they're saying you do not have to work it out. Just leave it right like that. Exactly like that. So part B is done. Part C is where the calculator comes in. And it says graph the function. Find the maximum volume that can be contained by the box and the size of the square cut that produces this volume. So how can we maximize how much our cake is? How can we maximize the size of our cake? That's how I'm thinking about it. All right, so what size, like little square, do we cut out in order for the pan to have maximum volume? So let's go to your calculator, and you are going to input this exactly how you see it in y equals. All right, so you're going to go down to y equals and put that equation in. Can't see all of mine because I took a picture of it. The equation was 16 minus 2x, 12 minus 2x, and x, all multiplied together. You should have it written down because that's part of the required answer on your homework. Now if you graph that, it's kind of a very tall graph, so unless you have a calculator that somebody used last period that's already done, your window's probably a little crazy, or needs to be a little crazy so you can see it. So go to window and put in this y minimum and y maximum, and that'll help your graph look a bit more normal. When you're done with that, your graph should look something like this. Now, let's think about it. We put into y equals, we put the formula for volume. So volume is the same thing as y. So our y-axis here represents volume. And what did our x represent? What does x equal? Back at the very beginning, we wrote down x equals height. It's h. Can either of those be negative? No. No. So we don't need this, and we don't need that little part. So what we do need is just this right here. That's the important part of our graph. And it wants us to maximize volume. So what point on this graph is your volume maximized? The top, right? Up there. So we need to find that point. Our calculator can do this for us. Remember? Second trace. Now let's see if this works. I recorded a video of me doing it because it was maybe more stable than me doing it on my own. Okay, so let's see if it works to play it, and I'll talk through it as it plays. Okay, so you press, ooh, that's bright. Second trace. And you go down, we're looking for a maximum this time, so you go down to number 4, select it, and you have to do left bound and right bound. So your left bound is over there, and your right bound is past the maximum. See the arrows blocking in that section? Press enter through the guess, and that gives you your maximum point. Do I need to play it again? You good? You remember how to do that? Okay, so wait, nope. Oh, I didn't take a picture of it. Okay, so remember that our Y represented volume. So what is our max volume? Remember, it's Y value, so this right here. 194.07. The units the picture up there gave us were inches. So what would our units for our volume be? No. Inches cubed, because volume is three-dimensional. Way to go. Okay, and then what would our x be to make this happen? What size squares do we have to cut out from the corners of our sheet of metal to maximize our volume? Yeah. 2.3 inches. So that is your answer to part C. So we have maximized it. So if you want the most cake you can get out of that sheet of metal, we need to cut little corners out that are 2.3 by 2.3. It's useful. It's real life right there. Well, somebody had to make it and design it. And every time you buy a cake pan, they're making money off of you. Okay. So, on your homework, number 13 and 14, the two problems right before this one, ask you to find the relative minimum, maximum, and the zeros. What are the zeros? Where it crosses the x-axis. So like this graph, no, this is good. So we have our maximum. We've already figured that one out. Then you would find your minimum down here. Same steps, you just select minimum. And then how many zeros does this one have? 3. 1, 2, 3. So you would have to find the zeros 3 times. Okay? I've recorded another video so that you can watch me finding one of the zeros. This is not one of the problems from your homework. It's just like it. Okay, so I'm going to find that 0. So I have second trace. It does that every time. That's annoying. Second trace. And number 2 is for 0. You make sure you're to the left of your 0, which in this case is above it. And then go down to the right until you've zoned in. Press enter, and one of the zeros for that problem would have been 6, x equals 6. So you would do that again for the other 2 zeros. Any questions? I recommend you go ahead and do 13 and 14 right now while you have a calculator, because all of the other problems you don't need a calculator for.